All right, guys, this is going to be the homework, or the lecture, sorry, for homework 6. Remember, we're going a bit out of order here. We're doing 5 and 6, then we're going to go back and look at 7 and 4 at some point next week. Actually, 4 are going to be Thursday, 7 will start next week. So homework 6 concludes fractions, specifically how to add and subtract fractions, but we'll also be talking about mixed numbers and improper fractions. We mentioned them last time, but we're going to go ahead and finish that stuff out today. First thing I wanted to mention, I got a couple emails about negatives on fractions. Probably should have mentioned this in the last video, so that's my fault. Where a negative goes on a fraction is irrelevant. All of these are the same thing. And this goes for mixed numbers, improper, and all that kind of stuff. So just to go ahead and get this out of the way, where you put a negative on a fraction, it's all equivalent. Whether it's negative 3 divided by 5 or 3 divided by negative 5, or the negative is just sitting off to the side. And it's just negative 3 over 5. These are all the same thing. These are all equivalent. Every single one of these is the same. So which one you use doesn't really matter. I tend to use the one where the negative is on the top, just because you don't really want to do common denominators, which is something we're going to do today with negatives. It's not impossible. It's not wrong. It's just more work. So personally, you're going to notice that I tend to put the negative up to the top. Even if let's say we did a fraction division question real quick. Like let's say I had 2/5 divided by 1/3. Remember how this, let's go ahead and just say negative 1/3. Remember how this works. This will be 2/5 times 3 over 1 because we flipped it. And I'm just going to go ahead and keep the negative up top. And that's what a couple of y'all were asking me about last time. So just a heads up, that's why I do it. I just like to keep the negatives on the top of the fraction. Is it required? No, but I don't know. It just kind of makes things a little bit easier when you're adding and subtracting, which again is what we're going to do today. So in terms of negatives, negatives can go on the top, negatives can go on the bottom, negatives can go off to the side. You're really no big deal either way. Wherever you like the negative to be is fine. The computer and on the test you shouldn't be getting marked off for really anywhere you put the negative. So that's just a little quick thing from last time. Something from this time, or new material rather, is mixed and improper fractions. Now, we talked about these mixed numbers and then improper fractions. We talked about these last time. Remember, a mixed number would look something like this, like 2 4/7, right? A whole number and a fraction. Whereas improper fractions will be things like where the top is larger than the bottom, 24 over 5, or could be negative, right? Negative 17 over 3. These are all improper fractions. And mixed numbers can be negative as well. Negative 10 and I don't know, 1/3, something like that. Okay, so just a couple quick examples of what they are. What we're concerned with in this homework is converting them into each other. It's primarily mixed to improper, but you all are going to have to do both. I really need to be very clear about this with you, so make sure you hear what I'm saying here. Both answers are correct. On a test question, if it doesn't specify, you could put a mixed number, you could put an improper fraction. As long as they're reduced, it's correct. So neither one is better than the other, which is why we're going to be converting back and forth. These are not equivalent to each other or anything, but we're going to be doing that in a minute, taking a mixed number, turning it into an improper, and so forth. So the idea here is to convert these, but again, in terms of which one you should leave in your answer, it does not matter unless the homework or the test specifies improper or mixed. Then it doesn't matter. So we'll start off with the first one. Let's go improper to mixed. All right, we didn't write that very nice. Let's try that again. Improper to mixed. Let's see if I can write this out like a human being. All right, it's a little bit better. So first example, let's take 28 over 3, which hopefully you would agree is improper. Let's go ahead and convert that into a mixed number. All right. So again, the ones above were just examples. This will be the first actual conversion. Remember what a fraction is. This is 28 divided by 3. So the nice thing, the first step about improper is to divide the numerator. I'm going to abbreviate here. This is not number, that's numerator. Divide the numerator by the denominator. All right. So in our case, we have 28 divided by 3. And I'm going to go ahead and put another note here. Use remainders. I don't like writing out a lot of notes on the overhead because the Sharpie's fat and it just eats up a lot of room real quick. I kind of just like to do examples, but here I think step by step is a little important. So 3 goes into 28. I mean, whether you do it longhand or not, it's totally up to you. 3 goes into 28 9 times, right? 9 times 3 is 27. And I said use remainders, so we're not doing decimals anymore. So this came out to be 9 remainder 1. Hopefully you agree with that. 3 goes into 28 9 times. 9 times 3 is 27. We subtract, and instead of bringing down, there's nothing to bring down. Instead of adding a decimal and putting zeros, because we're not doing decimals, we just have a remainder of 1. Okay, so there's 9 remainder 1. Second step, and really the last step here, keep the whole number, the 9, all right? Keep the whole number and put the remainder, which was that 1, remember, back over the denominator. Sorry, I'm starting to scribble again. Just trying to get it in there. Keep the whole number, the 9, and put the remainder back over the denominator. So in our case, to finish this up, we keep the whole number 9, we put the remainder of 1 back over the denominator of 3. So again, divide the numerator, 28, by the denominator, 3. 3 goes into 28 9 times with 1 remainder. Keep the whole number, 9, and put the remainder, which was 1, back over the denominator of 3. All right? So that's a quick example on improper to mixed. We'll do another example here in just a moment. All right, let's go ahead and do another example, and then we'll talk about improper to mixed. Get this stuff out of the way here. Let's say I gave you negative 19 over 4. Go ahead and go through the steps. See if you can convert this one on your own. First step was to divide the numerator by the denominator. So 19 divided by 4. Again, you can do this in your head if you want. 4 goes into 19 4 times. 4 times 4 is 16 with 3 left over. So overall, it was 4 remainder 3. Now be careful, this was negative. So we're going to keep that whole number, 4. The remainder was 3, which goes back over the denominator. The denominators are always going to be the same here. And here's the thing. Notice I didn't use the negative. It's not negative 19 divided by 4 with a negative 3. None of that. It's a negative mixed number or negative improper number. It's going to be a negative mixed number. If it was a positive improper, then it's going to be a positive mixed number. They're the same numbers. You're just converting between them. So be a little bit careful. Don't carry the negative around with you while you're doing the work. If the problem was negative, then the answer is negative, all right? Negative 19 over 4 converts to negative 4 and 3/4. All right, let's go ahead and box that off, because for the rest of this page, we're going to be going ahead and going the other way, and now we're going to be doing mixed to improper. You got to be able to go both ways, and this is honestly, I'm going to put a little star here. This is probably the more important one, because whether you convert your answer to improper number or mixed number, like I said, it just depends on the problem and the instructions from the problem. But oftentimes, when you're asked to add a mixed number or multiply by a mixed number, we'll talk about that in a little while, you don't want to do it. Mixed numbers require a whole other set of rules to work with. And you're going to notice today, I'm not going to use them at all. Anytime I have a mixed number in a problem, I'm going to switch it to improper and do it just with the same rules we've been learning for the last week, whatever. So don't get hung up here about converting these all the time. Most important is going from mixed to improper. If you're asked to, going from improper to mixed is there, but this is the one that's going to be most useful. So let's go ahead and just give an example. Start with an example. Let's say I said 8 4/5, and I wanted to convert that mixed number to an improper number. Well, think about how you converted over here, this improper to a mixed. You divided, right? Well, because we're going from mixed to improper, it's going to be the other way around. So I'll put the rules down here. And again, remember, this is done. Don't get confused here. That was from the last example, improper to mixed. Step 1, mixed to improper. You're going to not divide this time, but multiply the whole number, meaning the 8 in this case, right? And the denominator. So in this case, we're going to take the whole number 8 and multiply it by 5, which gives us 40. Again, you don't need to write out every step as you go, but just the first time, right? Second step, add the remainder, or in this case, what was the remainder? Do you remember where the remainder part was? It was the 4, right? Add the numerator, which again, I'm going to abbreviate. So now we have 40 plus, because we got 40 in the last step. Now we're going to add the numerator, which was 4. So 40 plus 4, that's 44. And the last step, which really you can say is just a part of the second step, put this number, meaning the number that you have now, back over the denominator. Because didn't we say last time, the denominator will not change. If you're converting between improper and mixed, the denominator is going to stay the same. So we took 8 times 5 and got 40. We added 4 to that to get 44. Now we're going to take that number, 44, we're going to put it back over the denominator. So 8 4/5 is 44 over 5. Again, notice, positive number, positive answer. It's just a conversion of the same number. The signs should not be changing here, all right? Let's go ahead and see if we can't squeeze one more example here in the bottom right. Let's say I said -9 1/10. How would you convert that to improper? Think about how you do it, follow the same steps. Multiply. And remember, like I said, don't carry the negative around through the problem with you. If it's a negative improper or negative mixed or either way, it's going to be negative improper. Whole number times denominator, 9 times 10 is 90. Add the numerator, +1, that'd be 91 back over the denominator, which was 10. All right? So just make sure you understand how to convert between mixed to improper and improper to mixed. And one more time, it does not matter which one you leave as an answer unless the instructions say specifically, which honestly, they're most of the time going to want improper, just because that's kind of the easiest way to do it mathematically speaking, even though maybe in the real world we prefer mixed numbers. All right? So that's improper to mixed, mixed to improper. That's just, some stuff we needed to get out the way. The focus of this homework is really on adding and subtracting fractions, although the mixed numbers will come back into play. All right? So sort of moving into the second phase of the homework here, or the lecture here rather. All right, so let's talk about how to add and subtract fractions. At its most basic level, it's pretty straightforward. If you add A over B plus C over B, again, key being that they're both over the same number, this number over something plus that number over something, you simply just add the tops and keep the bottom the same. And this actually worked for subtraction as well, so we can go ahead and say plus or minus. So there's your rule for adding fractions. That was easy, right? And it is easy as long as it's set up like that. So if I said 3/5 plus 8/5, well, they both have the same denominator, which is called the what? The common denominator. This is required. This is required when adding and subtracting. Go ahead and put a star there. When you add and subtract, you must have a common denominator. This is not required for multiplication division. You know that already, but just a reminder. So we already have our common denominator of 5. We keep the denominator whether we're adding or subtracting, and then we either add or subtract the tops depending on what it says. 3 plus 8 is 11. No big deal. All right? So at its most basic, that's how you add and subtract fractions. You just add the tops together, subtract the tops together, and keep the bottom the same. Another example here. If I had -7 over 3 plus 3 over 9. Now we could go ahead and reduce, 7 over 9, not 7 over 3, excuse me guys. -7 over 9 plus 3 over 9. We could go ahead and reduce the 3 over 9 to 1/3, but I don't want to do that. We have common denominator, and that's the point. So 9 on the bottom, right? Keep the denominator the same. -7 plus 3, those don't add, right? A negative number and a positive number. Don't forget your sign rules. They're going to subtract. 7 minus 3 is 4, and keep the sign of the larger. So -7 plus 3 is -4, and again, back over 9. What if there's more than 2 of them? It doesn't matter. If there was 3 of them, it's really the same principle. There's that -7 over 3 I was trying to get in the last problem. So here's another one where there's 3 over 3 over 3 over 3, so all common denominators, so no problem. This makes it nice and sweet. Our denominator's 3, and then we just put the tops together. And in this case, they're all negative, so we can go ahead and add them all together. -11 and -7 is -18. -2, that's -20 over 3, right? No big deal. Just for practice, let's go ahead and convert that to mixed number. Again, though, remember, it is not required. This is reduced, so that answer is fine. It just depends on what the instructions say. Negative improper will turn into a negative mixed number, remember. 20 divided by 3 is 6, which would make 18, which would mean we have 2 left over out of the 3. So again, unless I specify, you could leave either of those answers, wouldn't be a problem, all right? So in a nutshell, in the easiest sense, that's how adding and subtracting fractions works. If the denominator is the same and you add the tops or you subtract the tops, or if they're all the same sign, you add them all together and keep it negative, just depending on the scenario and the signs. But again, as long as the bottoms are the same, it's really a triviality. The issue, obviously, is what happens when the denominators are not the same. And they are not going to be most of the time. So that's the thing you should be aware of. Most of the time, you're going to have to do what we're going to be doing next, which is finding the LCD, finding that least common denominator, all right? So this is really more or less where the true work starts. So let's start with something where we don't have equivalent denominators. Negative, or let's do positive. 3 over 5, we'll get into the negatives in a minute, plus 3 over 10, all right? 3 over 5 plus 3 over 10. I'll try to write that a little bigger in a second. Notice the denominators are not the same, right? So that's our first problem. We have numbers where the denominators are different, and they will not add like this. This simply will not add. You cannot do this if you ever add numbers with improper, or excuse me, try that again. If you ever add fractions where the denominators are not the same, it's wrong. Just guarantee it, it's wrong. So first thing we need to do is come up with a common denominator, or as people like to come up with, the least common denominator. It does not have to be the least, really. It could be anything that 5 and 10 can both make. Hopefully, I think y'all agree this one is 10, because we can turn 5 into 10, and 10 is already 10, so least common denominator would be 10. You could get a common denominator by multiplying them together. That will always work. 5 times 10 would be 50, but that's not the least common denominator. Would it work? Yes. Would it cause you to have to do more reduction at the end? Yes. So we'll just keep it simple for now. We'll keep it 5 and 10. Hopefully you agree the least common denominator here is 10, meaning what is the denominator we can get them both to make? Well, we can't go down. We're not going to make these go smaller, so they can only go up. The big, or the smallest number that 5 and 10 can both go into is 10. So that means this one's okay. 3 over 10 is where I need it to be, isn't it? It's already got that common denominator 10. This one I need to adjust. So what I'm going to do, I'm going to try to get this in small, so make sure you see what I'm doing here, is I'm going to multiply the 5 by 2 to make it 10. If I want the denominators the same, then make them the same. But, and I'm sure you remember this from whenever you were taught this long ago, what you do to the bottom, you got to do to the top. So what happens here is we said, well, I want the bottom to be 10, so 2 times 5 is 10. Well, you did 2 times 3 on the top as well to give you 6. So now that one turned into 6 over 10. This one over here is 3 over 10. Now we have a common denominator. You probably know what to do. It's going to be 9 over 10. Now, you will need to check these for reduction. Adding and subtracting, unfortunately, there is no way to tell ahead of time if it's going to reduce or not. So in this case, we ended up with 9 over 10. 9 over 10 doesn't reduce, no big deal, so we can leave it. Let's do another one. So again, this is where most of the work is going to be, is getting these common denominators and adjusting your fractions to make them have common denominators and so forth. So let's say I said negative 5 over 7 plus 2/3, all right? First things first, come up with a common denominator. What can we get that both 3 and 7 can be made into? Well, probably 21, right? So that's the other thing I'll say to you. If the answer is not obvious, like hopefully the last one, 5 and 10, the answer is 10. If the answer is not obvious, you can always multiply them together. You can always take the denominators and multiply them together. Will it always give you the least? No. In this case, it did, but it will not always. And we'll do an example of that in just a second. I'll show you where multiplying them together would not be a good idea. Well, actually, you can see it in the last problem. What if I had done 5 times 10? I would have gotten 50. Is that a common denominator between 5 and 10? Yeah, it is. But these numbers would have been much bigger if I'd used 50. This would have been bigger, and I would have had to reduce it back down. So use the smallest denominator whenever possible. It's not always possible to get a nice small one, but use the smallest one when you can. So in this case, we need a common denominator of 21, because 3 can be made into 21, 7 can be made into 21, and once they're both 21, it won't be a big deal anymore. So first things first, let's take the negative 5 over 7. What am I going to have to do to make that one have a denominator of 21? Well, multiply it by 3, right, on the denominator. But what we do to the bottom, we have to do to the top. So what we have now is negative 15 over 21. All right, that's what that one turned into there. Okay, now the 2/3. We want this to have a denominator of 21 as well. So I'm going to multiply the denominator by 7 to make 21. What you do to the bottom, you do to the top. This was positive. 2 times 7 is 14, and 3 times 7 is 21. So now, hopefully you see the 2/3 turned into 14 over 21. The negative 5 over 7 turned into negative 15 over 21. We have negative 15 over 21 plus 14 over 21. Combine these together, just the tops, remember. You're going to get negative 1 over 21. So once again, we got nice and lucky here. We didn't have to reduce. Again, you will need to watch out on these because reduction is always possible, all right? Take a minute, make sure you're cool with that. We'll do a few more examples here. All right. All right, let's take a look at an example, one more basic example where the denominators are not the same. Let's say I said, let's go with -7 over 24 minus 5 over 12, something like that, okay? So one more example, just here with the, well, not one more example, but one more smaller example, -7 over 24 minus 5 over 12. Think about what your least common denominator here would be. What's the smallest number 12 and 24 can both make? This is another example where you could multiply them together. 12 times 24 will give you a common denominator, but it, oh, what is going on with the focus there? I don't know what just happened. But 24 and 12, the least common denominator is going to be 24, right? Can't 12 be made into 24? Can't, and 24 is already 24. So you don't always want to just jam them together and make a huge number out of this. So once again, we have a scenario where the first fraction is already good to go. I don't need to mess with it. It's already got the common denominator I want. It's this one over here I need to be a little bit careful with. I want this one to have a denominator of 24. So I'm going to multiply by 2 down here. What you do to the bottom, you do to the top, which gives me -7 over 24 minus 10 over 24. Once the denominators are the same, all the work's done basically. -7 minus 10, they're both negative, so we'll add them together, keep it negative, -17 over 24. All right, so just one more quick example there for you guys on one where you probably wouldn't want to sit there and smash the denominator together, okay? Now, what if there's more than 2 fractions? What if there's more than 2 fractions? And it, you know, it really shouldn't get too much worse. I mean, there might be 1 or 2 questions in the homework where they kind of push it with bigger numbers, but generally speaking, finding a denominator is not something you want to sit there and do for 30 minutes. You want to be fairly quick with this. So take a look at this one, -6/5 plus 11 over 6 minus -8 thirds. There's a couple ways to approach a multiple fraction problem. You can do the first 2, get whatever you get out of that, and then take this one on. The problem with that is you're going to be finding a common denominator here, cleaning that all up, then finding another common denominator here, and you're basically going to be doing 2 problems. These 2, and then that one. I personally like to do all these at once. So 5, 6, and 3, what would be your least common denominator here? Well, another way to do this, and this is kind of a slow way, but it will work, is you can take the biggest number, which in this case would be 6, and you can start counting up with it. 6, well, 5 doesn't go into 6, right? So that one's out. 12. Well, 5 doesn't go into 12, so that's out, right? Remember trying to find something they can all make. 18. 5 doesn't go into 18, so it's out. 24. 5 doesn't go into 24, so it's out. 30. 5 goes into 30, 6 goes into 30, 3 goes into 30. Our common denominator, our least common denominator would, in this case, be 30. So again, you can always take the largest of the denominators and just, you know, check each iteration of it until you find one that works. Another possibility, although personally I think that is a lot of work to do most of the time. So let's go ahead and do this on another sheet of paper. Actually, I'm going to continue this, but I just don't want to have to cram this all in. So let's do this. Let's do this. Let me rewrite it here. We'll have all the room we want. -6 over 5 plus 11 over 6 minus -8 over 3, which you probably already converted in your head to positive, which would be good. Our least common denominator, we just agreed, would be 30. All right, so let's take that -6 over 5. How do we get that to have a denominator of 30? Well, multiply the 5 by 6, right? That's what makes 30. Just don't forget what you do to the bottom, you're going to have to do to the top. So this is going to turn into -36 over 30. The 11 over 6, the positive 11 over 6, we need that one to have a common denominator of 30. So what I'll do is I'll multiply the bottom by 5, multiply the top by 5, and this will give me 55 over 30, positive, right? 11 times 5, 55, 6 times 5, 30. The last one, negative and negative is positive, so we can go ahead and put that, and that's positive 8 thirds. We need a common denominator of 30, so I'm going to multiply by 10 on the bottom. What you do to the bottom, you do to the top. positive. 8 times 10 is 80. 3 times 10 is 30. And now, hopefully you agree that we have a, not a big deal any longer because the denominators now all match. All we got to do now is go ahead and add them all together. We know our denominator is going to be 30. 55 and 80, right? Just do this by hand if you need to. Not a big fan of doing addition and subtraction in your head. It's when you kind of make mistakes, right? So we got 135 from 55 and 80. Now we're going to take 135 minus 36. You probably know it'll be 99, but no big deal if you need to go through it. 15 minus 6 is 9. 12 minus 3 is 9. So we got 99. Positive 99. All right? So take a minute, catch up, make sure you agree. And then hopefully you're screaming out right now, this isn't done. Because if you leave this answer, my friends, you're probably looking at half credit. The test is pretty ruthless about half credit. It doesn't give, about unreduced fractions. It doesn't give a lot of credit for them, about half. And you did all this work, and now you left your answer in an unreduced format. How do I know that? Because doesn't at least 3 go into both of these? 3 goes into 99 33 times. 3 goes into 3 goes into 30 10 times. And now we have 33 over 10. That seems reduced. If you'd like to convert this into a mixed number, see what you think it would be. 33 divided by 10 would be 3, with 3 left over. Either one of these answers is fine. Again, as long as the homework doesn't specify it's got to be improper or it's got to be mixed, either one of those answers should be fine. Take a minute, make sure you're cool with this, because this is kind of, one of the longer, uglier problems in the homework. Couple other things, and that'll wrap us up. Luckily, this isn't a super, super long homework here. There's a couple questions in this homework and in the last one. You could do these a couple of ways, but you might find them a little easier now. They would ask you things like 4/5 versus, let's say, 7/9. And it would ask you, which is larger. Or it might say, put a greater than or less than sign in there. Which is bigger? Which is smaller? Well, you can't really tell right now, because 4 out of 5 and 7 out of 9, and that's actually pretty close. And if you kind of drew it out, if you drew all the fraction pieces out, it would look very similar. So the way to tell this is with common denominator. If these were both the same denominator, all we'd have to do is say which has more pieces up top, right? So 5 and 9, what would your least common denominator be? And again, it does not have to be the least. The least just means less work. 5 and 9 would be 45, wouldn't it? Okay. So if we have 4/5, I'd want that to be 45 as the denominator, so times 9 on the bottom, same to the top. And that's going to give us 36 over 45. Remember, we're not adding or subtracting, we're just comparing here. 7 over 9, I want the bottom, the denominator, to be 45, so I'm going to multiply by 5 here, top and bottom. 7 times 5 is 35. 9 times 5 is 45. And so you see that these were extremely close. 36 out of 45 versus 35 out of 45. Well, 36 out of 45 is bigger. So 4/5 is bigger than 7/9, but only by the smallest of margins. So just another way you can do some of those problems where they ask you which one's bigger, which one's smaller. Okay. Let's go ahead and with the remaining space, which we should have enough for. Let's go ahead and do an order of operations problem here, because you guys seem to like when I do those on here, so we'll go and work one out. Remember now, we have all the order of operations in effect now, other than exponents and roots. We have adding, subtracting, multiplying, dividing, parentheses, all that stuff, okay? So if you got a problem like that in the homework, which you will, there's a couple of these. 6 minus 2/9 divided by 7 plus 1/3. Hopefully you agree right off the bat we need to go ahead and do what's in the parentheses first before we worry about the division. So we've really got 2 small little addition problems to do here. So we'll do this one over here. 6 minus 2/9. What would we do with that 6? Well, I'd probably want to go ahead and convert that 6 to what? 6 over 1, right? And if I had a mixed number, I would want to probably just convert it to an improper fraction, because it's so much easier to use. Mixed numbers require their own set of rules. Do not add and subtract or multiply and divide with mixed numbers. Which you can call a 6 a mixed number, I suppose. Turn them into improper fractions. Trust me, it's just going to make life easier. All the instructions we've given have been with improper fractions. So 6 over 1 minus 2 over 9. Common denominator for these two, least common denominator here would be 9, right? So luckily, this one's already got a 9. All we need to do is convert this one. So times 9, let's squeeze this in here, times 9. 6 times 9 is 54. 1 times 9 is 9. We already have 2 over 9 here. So this first fraction works out to be 52 over 9. Not first fraction, excuse me, first parenthesis. We had 6 minus 2 over 9. We turned that into 6 over 1 minus 2 over 9. Then we made common denominators. 1 times 9 is 9. 6 times 9 is 54. 54 minus 2 is 52 over 9. So that's what that first parenthesis turned into. The second parenthesis, we have 7 plus 1/3. It's going to be very much the same. We're going to go ahead and make this 7 over 1, just to make it an improper fraction, plus 1/3. Our least common denominator here would be 3. So fix it on the left side here because the right one's already good. 7 times 3 is 21. Over 1 times 3 is 3. Plus 1/3. 21 over 3 plus 1 over 3 is 22 over 3. So take a minute, catch up. First parenthesis turned into 52 over 9. Second parenthesis turned into 22 over 3. Now we're going to go ahead and just divide them in the middle. So we had, let's go ahead and make our little boundaries here. We had 52 over 9. Working on a very small piece of paper, guys. I normally am used to like a big board where I can erase and move around. So the little crunching of room, I apologize. If you can't read anything or if anything's an issue, just let me know. So we have 52 over 9, the first parenthesis, divided by 22 over 3, the second parenthesis, second fraction. Remember how this works. You keep the first one, you change it to times, and you flip the second one. Don't forget how this works. Okay? We can do a little cross canceling here now that it's times, right? 3 goes into 3 once, 3 goes into 9 3 times. Go ahead and multiply, and that'll give us 52. 52 times 1 is 52, and 3 times 22 is 66. So this worked out to here, this worked out to here, and now we're at 52 over 66. And I ask you, are we done? Hopefully you agree. We've got one more small step to do. We've got to reduce this by 2 maybe. 2 goes into 52, 26 times. 2 goes into 66, 33 times, and just finished and ran out of room all at the same time. That was perfect. So take a minute, go back over the bigger problems, guys. No one's asking you to look at this and just, knock this out in 20 seconds. Take the first parenthesis, work it out, get your answer. Take the second parenthesis, work it out, get your answer. Now you have 2 fractions you're dividing. Keep the first one, change it to times and flip. Did a little cross canceling, got our answer, and then reduced it. So take your time with the notes, guys. As I always say, feel free to pause, review, rewind, no big deal. Let me know if you have any questions, and I will see you guys in the next one.